Hello, my friend. This is SHYSKYTECH Corporation Limited, the professional manufacturer and designer of micro-brushless DC water pump products of various power levels. Of course, yeah. Okay, I record this video about this heavy-duty motor speed adjustable version of our series. This is SHYSKY's DC80E-24100A-1 model. This is the version that is offered to our universal users. This is the heavy-duty pump. Pump body part, the brain part, and the power cord, and also the potentiometer knob. Yeah, it's a rough view of the whole pump. About this pump itself, it works by the at 24 volts DC powering, a safe low voltage DC power supply, and the power consumption is about 150 watts. Yeah. So the working current is about 6.5, around 6.5 amps. Yeah, I think so. Almost. Yeah. And the max static lift of this pump is about 10 meters at 24 volts DC. In the meantime, the max horizontal flow rate can reach about 8,000 liters per hour. So it is quite a good power circulation water pump, yes. When compared with DC80E, our more powerful pump, a bit off topic, but here I see DC85E-24100A model will be a more powerful version, a larger version than this one. And it will be 200 volts at 24 volts DC, and the max static lift is about 10 meters, while the max horizontal flow rate can up to 13,500 liters per hour. This is 8,000 liters per hour. Okay, it's a bit off topic. Let's pay attention back to our DC80E pump. Let's get it out. This is inlet, this is outlet, right? Both are threaded. One is threaded with the external diameter about 32 millimeters. Yeah, inlet, outlet. This is the base part, and this is the pump body part. This whole pump can be waterproof, so it is okay to be placed the pump body underwater when the installation. Yeah, or it can be okay for the land use, namely the both inlet and outlet being connected with our external matching hose. But here we know that our pump works by the high-speed rotation of impeller within the cavity of the pump to push or throw the water inflow out of the outlet to achieve the performance of the pump or water pumping. And our pump cannot be self-priming since it works by the centrifugal force of the impeller rotation. So normally our pump can support being installed in two ways. One, it is submersible installation underwater, namely, for example, this is the water tank, and this is the pump, power supply, fixed underwater. The water can actively and sufficiently flow into the inlet of the pump, and the pump will pump the water out to a destination container. This is installation one, submersible installation on the water, right? Of course, the control box part be not placed on the water when the installation. I will talk about it a bit later. Or our pump can support being installed at land use, namely our pump being connected with the hose and external hose. This is pump, yeah, power supply. And in this bay of installation, make sure that the water can actively flow into inlet, because our pump cannot be self-priming. If it happens the water is here, lower than the inlet, and our pump needs to absorb the air and absorb the water from lower location to outer, this is not supported. This will be not supported. Pay attention. Okay. It's about the working mechanism of the pumping. And then Let's take a look at the follow-up parts of the pump. This is the tail side. This is the waterproof connector, since our pump adopts the modularized design style, as we see. This is the control box part. Actually, the main control and protect circuits of the whole pumping system are actually integrated within. So we can call it the brain part of the whole pump. Body part, the brain part. And here it is the power cord and the potentiometer knob, right? All together is the whole pump. Yeah. Sometimes users may do not understand what this control box is used for. It is the brain to control the pump's running. Okay. Where the installation, the control box part is not recommended to be placed on the water. Yeah. Not to be placed on the water, but place it in somewhat dry and low location to keep the reliability and stability of the electronic components within. Yeah. Okay, let's take a look at the power cord. Let's get it closer. This is the gap, right? And this is the customized 4-pin connector. If we look at it anti-clockwise way, this is pin 1, the first pin 1, the second pin 2. Pin 1 and pin 2 actually together handles the positive polarity. So pin 1 and pin 2 is positive. The other 2 pins, pin 3 and pin 4, are negative. 2 pins are designed to handle one polarity because, as we see, our pump's working current is over 6 amps. So it is high working current. And this design style can reduce the working current to each pin, and will keep more reliability when the pump works in the system. Okay, let's draw it briefly. This is the gap, right? Pin 1, pin 2, positive, and pin 3, pin 4, negative. DC 24 volts. Yeah. Essentially, if this style of connector are actually not convenient to be found on market, and if you have 2, we can cut it off. There will be undoubtedly 2 sub-cables within. One will be positive, normally red and sometimes brown. The other will be negative, black, or sometimes blue. Yeah, negative, positive, DC 24 volts. If we cut it off, as the DC appliance, this pump being a DC appliance, DC 24 volts, as we see, there will always be 2 polarities, no matter what the style of connector is. Yeah. Of course, normally we do not offer the converter to our users, but really need to. We do have the converter cable, but of course, it is charging. Yeah. This can convert the 4-pin connector to the 2 sub-cables, right? And the linked cable can be conveniently being plugged with our various types of power supply, DC 24 volts power supply. We can try the connection here. Yeah, and this is the waterproof ring. Right now it is 2 polarity, black and red. DC 24 volts. This can only be offered based on special demand and based on surcharge. We have to admit this effect. And about the power regulation way. Normally, our pump, it is always equipped with the potentiometer knob. So let's mark it. First, our power regulation way, speed adjustable way. The first way is potentiometer knob, right? Where the users can rotate the potentiometer knob to adjust the power and flow when the pump works in the system to make it more flexible to adapt to different parameter demands. in the cooling in the small circulation system to medium system. Yeah, okay. This is potentiometer knob. It is always in default to be offered to universal users. And in some special scenarios, we can customize the speed adjustable weight to the 0 to 5 volts analog signal injecting, yes. But this can only be offered based on customization on the premise of MOQ and lead time. Otherwise, it is not offered because our engineers will specially modify the circuit. Yeah. Here I will briefly introduce it too. If it is a version that supports the 0 to 5 volts analog injecting signal input, yeah, there will be, of course, not a potentiometer knob, but will be two connectors. Normally, it will be yellow and black color. Yeah, the yellow color cable connector will be connecting with our control signal, and black will be connected with our GND ground of the system. More precisely say, yeah. Actually, our pump, the electronic components have a start-up current, the current or the voltage. Yeah. So perhaps when we injecting 0 volts signal to the yellow connector, the pump, of course, is not working, right? And 0.1 watts, maybe it is still not working. Perhaps 0.15 or 0.2. It differs because of the derivation of different electronic components. Yeah. So we can simply say 0 to 0.2 watts as the startup regulation voltage. Okay. And when the regulation voltage is over about 4.2 watts, the pump's power may already reach its peak value, the max value of this pump at this moment. And when we further increase the regulation voltage from 4.2 watts to 5 watts, the power of the pump may be not changed anymore because it already reached its maximum value. So we can more precisely say the more valid control signal range could be 0.1 or 0.2 watts to 4.2 watts around. Why 4.2 around 4.2? Because when the pump is connected in the system, there exists the pressure and the working current will be decreased. In the meantime, our power regulation is based on the working current essentially. So the working current is decreased when it is out, it is just open, yeah. So the real valid regulation voltage decreases to around 4.2 watts. Not so precise, but this range could be more valid range. But in general, we can see we inject our pump with 0.5 watts analog to control the pump's power and flow. Okay. And third way, PWM signal control. PWM, 50 to 800 Hz. We can choose one specific frequency within this range, amplitude 5 watts. Yeah, our pump can be customized in this way to be regulated. And it will also be two cables, yellow and black. Yellow will be signal port and black will be GND port. But note that the 0 to 5 watts or PWM can only be offered based on customization on the premise of MOQ and lead time. Otherwise, it is not offered. Yeah, only this one. And about our pump, it is actually a quite powerful version among our series. As we see, such a small size and relatively low power, it can offer quite good energy to our users in the system. And Obviously, it is bigger than most of our micro brushless DC water pump. This is the larger one, DC80E, and this is the smaller one, our DC55 series. Yeah. So a very small 80 watts, 24 watts too. This is 150 watts, 24 watts. Yeah. And it's just a brief actual comparison. Okay. So if you're interested in more details, you can contact us and we will offer necessary technical support, yeah, within our capacity. And thank you for your time. SHYSKYTECH.